Folks, this chapter will be about time value of money. We are going to particularly look at, let me just change the color, and so future value, present value, we do I and N, annuities and rates of return, and no amortization. Okay, so we have different kinds of cash flow. Most important part is that whenever you do the time value of money, create a timeline like this, even if you become an expert. And so you see CF0, CF1, CF2, CF3, and all those. And I is the percentage by which it is growing. If it is going this way, future value, or if it is going the other way, then it's present value. So you say present value, you call this discounting at I%. Future value, you call this compounding at I%. Now, there can be various timeline, and when you draw the timeline, and then you see where the cash flows are coming in, and at that point in time you just do the needful. It's a $100 lump sum due in 2 years, so this is the amount that is due in 2 years. And then 3-year ordinary annuity, and ordinary annuity has two conditions. One is that equal amount, and the other one is equally spaced. That means you have this 1 year, this is also 1 year, so 1 year difference, 1 year difference. So that's ordinary annuity, and it is happening at the end of the year. So it is like December 31st of a year, and another December 31st, and then another December 31st, ordinary annuity. So we'll talk about that more. And then this is the more enriched version of cash flow. That means you have no annuity in here. It's uneven cash flow. And time value of money can be applied here, but that is more time consuming. You apply for uneven cash flow some cash flow mechanism or cash flow methods. So let's do some problems. Here we have happening 100 in here. So now you see how many compounding? 1, 2, and 3. 3 compounding. So in order to solve the problem, first we show you mechanically applying this formula, and then you see first one is 104, second one is 108, 112. So we then go to the calculator that you have, or that I asked you to have, and you see N is number of compounding, and I showed you last slides. N is 3, 4 is percentage, present value in negative, and then payment is 0, and FP. So it is always good. There are 5 variables, N, I, PV, payment, FV, and you have to fill in everything. If there is nothing, then call it 0, and then compute future value. And once you do that, you get 112.49, which is what you got in here, 112.49. So then we go to the next one called present value, and this time you get 103 years from now, and then you see it will have to be coming back to this. And what you now see, that how many discounting. So 1, 2, and 3. So those are 3 discounting. So N should be 3. So in a lump sum, present value of lump sum or future value of a lump sum that we had been dealing with, N represents number of compounding or discounting So if you apply the formula, just like future value, you get 88.90. So obviously money at distant is worth less. Now you can do that. N, you put n equals 3, 4 is I, present value is that what you are going to compute, and payment is 0, future value is 100, and you get all those 88 something. And what is the number you got here? 88, yeah, 88.90. Then we solve for I, and let's say $100 grew to 119.10 in 3 years. So you put n equals 3, present value 100, payment 0, future value is 119.10, compute I, it is 6%. And then for n, this kind of question is very intuitive. You are interested to know that how long will it take to double your money, and to do that you think that, well, there are 5 variables, you have to have 4 numbers for 4 of them, but here they give you just I. And but did they, by asking how long before sales double, they have already given you 2 more, which is if you think present value is $1, then future value should be $2. If you think the present value is 50, the future value should be 100. So here they assume 1 and 2, and then 10%, and the payment is 0, and is 7.3. However, there is another rule of 72, and the rule of 72, especially for this, you say use 72 and divide it by the percentage. What is in this case is 10. So if you do that, it is 7.2 years. That's a very quick way of ad hoc way of doing things, but it will be approximately the correct answer. But don't do that on your exam. You'll have to do this by your calculator. Now let us talk from lump sum. We are going to now go to annuity. There are 2 kinds of annuity. One annuity is the one that I showed before. You get at the end of the period, and then once you get payments like that, that's one. The other one is at the beginning of the period. This is what you see amount. Ordinary annuity is this one, and this is annuity due. Alright, what do you see here? The difference is that ordinary annuity will be less than annuity due. Why? Because it is compounding more. So then even the last one is not compounded at all, but here the last one is compounded one more time. So what I suggest that you do not have to do annuity due separately. You do ordinary annuity as if it is ordinary annuity, and then you multiply ordinary annuity amount with 1 plus I. So I'll show you that. Solving for ordinary annuity, you put n. Now when you move from lump sum to annuity, n represents number of payments, not number of compounding, number of payments. So there are 3 payments: interest, present value, payment, and then you compute for future value. Once you do that, let's see how much it is. It is like this one here, 312. Now what I was suggesting, that if they say that what if this is annuity due, you take this 312.16 and just multiply it by 1.04, and that should be your answer. I'll show you what it will be. 324.65, 324.65. All right, so present value exactly same way, and then you do the annuity due method is just put it from end mode to beginning mode. Once you do that, you get 324.65. All right. I do not recommend doing this, changing ending mode to beginning mode, because you may forget to do put it back to ending mode, and if you on your exam, if you forget that, most of the answers questions will be on the end mode. So here it is. They also say that this can be done this way. All right. So we get to do the same thing with the present value, and again you can do it this way. You do the ordinary annuity and then you multiply it by 1.04. all right, now let's go back to doing present value calculations, and here you see 5 payments, 4%, 100 is the payment each time, and future value is 0, we get 445. And then one thing that you need to understand is that longer the annuity, higher is the value waiting for you. So these numbers are higher. Well, if somebody asks you this question, that what would be the most the money can grow to, let's say you have $100 at 4%, what would be the most? Answer is perpetuity. We look at for perpetuity, and this is the most that it will grow to. Then you have an interesting question, that is, you are 20-year-old and you want to save $5 a day for your retirement, and then that becomes $18.25, and then how much will be this $18.25 be worth at 8%? Excuse me, when you are 65. So you put the 45 years, 8%, present value is 0, and 18.25 is the payment. That's your future value. What if you did not do that when you are 20 years old, but you started doing it at 20? You see, only money that will be available is 133. You lost this much just because not investing. So it is always investment. The key is that you start investing as early as possible. Now if you try to make up this 571, then of course previously you were putting 18.25 per year. Now you'll be doing 5 times as much, close to $10,000 that you have to invest to reach this 705. Now when you have an uneven cash flow, that becomes time consuming for you, because you have to take each lump sum separately and then take it to year 0. But there is a better way. Better way is the cash flow way, and that is what I strongly recommend that you do. You put cash flow 0, then 1, 100, and so forth, and cash flow 5 is a -50. Enter I, and then press NPV button in there to get NPV of 597.48. So learn that and use that for uneven cash flow. Even you can use it for even cash flows, the one that we did for simple lump sum or ordinary annuities. So cash flow can do what time value of money or TVM can do, and more. So if you see the distinction between frequent compounding versus only once, so this is compounding once, and then once you do that you get 112, but if you do it twice, compounding twice, 112.62, even though the difference seems to be lower, but frequent compounding will make it bigger. And what you see here annually, this is happening there are only 3 years. This is 3 years. But now here there are 6 periods because semi-annual is twice. All right. Now there are some few remarks on nominal rate versus periodic rate. And nominal rate is the one that is stated when you go to the bank. It's on the board. And periodic rate is how many times you are compounding. When m is equal to 1, you are compounding once. When m is equal to 2, you are compounding twice. That is semi-annual. Quarterly would be m equals 4, and monthly will be m equals 12. All right, so this is the equation that is the way you change the nominal rate. Nominal rate is converted to effective rate, and so for if it is doing compounding twice, then it should be you divide by 2 and multiply by 2 to the power 2. So this is 4.04. When if somebody asks you that can there be any other scenario where periodic rate and nominal rates are the same, you say yes when m is equal to 1. So let's say this is just 1 compounding, this is 2 compounding, this is 4 compounding, this is 12 compounding, and this is 365 compounding. All right? And you can see that from 4% it goes to 4.08. All right, so this is the question. They say, can there be any time where periodic rates and effective annual rate are the same? You say yes, m equals 1. And then we look at anything. If it is compounding occurs every 6 months, you say 3 years becomes 6 periods, and this is after 1 year, this is after 2 years, this is after 3 years. Okay, and you have to change now. You see it becomes 4%, becomes 2%, and n becomes 6. So you take I nominal and divide it by number of compounding, and then you take which is 4% divided by 2 is 2%, and that you see in here. And then you take and multiply it by 2 is n is 3 years, multiplied by 2 is 6. And these are the inputs that you are going to do on your calculator. N is equal to 6 and I is equal to 2%. So, or what you can do is you change this to effective annual rate, and then this is the way you go. 4.04 is the effective annual rate, and you get this number. Now once you do that, this is for ordinary annuity and semi-annual compounding. And then the last thing that I wanted to say is that we are not going to do loan amortization here. So if you have any questions, let me know, and thank you.